there's a 25% chance of getting this multiple choice question correct. Okay, why is there a 25% chance? Because usually your MCQ questions are just 4 options. Okay, so if each option has an equal probability of being the answer, okay, then it will be a 25% chance, right? Full 100% will be for total. Okay, or maybe you will say Miss Kang will probably scold us if you don't do, if you do this or if you do that. Okay, I cannot predict whether Miss Kang is going to be on leave today or not. Okay, so you're talking about prediction. Okay, a probability. Alright, we make such statements because we are uncertain whether an event will occur or not. Okay, so we give a number to it. Okay, so for an uncertain event, we talk about chance of occurrence. And for this measure of chance, okay, which is going to take values from 0 to 1, it is going to be known as probability. Okay, so in probability, we have this discussion about sample space as well. Okay, and sample space is all the possible outcomes that can arrive, okay, when we do a certain thing. Okay, and when we perform a certain thing, we call it an event. Okay, in the terms of probability. Alright, so for example, a probability experiment, there's an event. Looking at your first page, there's a table, right? Okay, when it comes to tossing a coin, okay, when you toss a coin, it is either you get a head or a tail. Okay, so the total number of possible outcomes will be 2 possible outcomes. Either you get a head or you get a tail. Okay, and the sample space is limited to head or tail only. Alright, so let me write that down. Okay, so the sample space consists of head or tail, right? Which has already been printed inside your notes. Okay, then the number of possible outcomes is 2. Okay, then after next, if you roll a die, right? I hope you are aware that one die is considered a die, D-I-E, okay? Dice, D-I-C-E, is a plural form, okay, when there is more than one die itself, okay? So the sample space for rolling a die, we know that on the die, what kind of numbers are on the die? 1 to 6, right? So the sample space will consist of the numbers 1, 2, 3, 4, 5, 6. Okay? Then after that, how many possible outcomes are there? There are 6 possible outcomes. Good. Okay, then the third one, we have cards number 11 to 20. Okay, what do you think the sample space would be then? What would the sample space be? What do you think, Ryan? 11 to 20, okay, it will be the numbers, alright, from 11 all the way to 20. And then the number of possible outcomes, what would that be? How many possible outcomes are there? 10. Okay. Consists of 2 black balls and 3 white balls inside. Okay, so when we have such a situation, right, we will number, okay, the balls. So the black balls that are stated inside the worksheet, we let it be B1 and B2. Then whereas for the white ones, okay, we call it W1, W2 and W3. So therefore, when we distinguish the balls, okay, and name it, alright, the sample space itself will have to have the distinction. Okay, so we have B1, B2, W1, W2, W3. So the total number of possible outcomes will actually be 5. Okay, this is if we actually distinguish the models itself. Okay, any questions up to here? Right, so we need to be aware of what is the total number of possible outcomes, okay, so that we can determine the probability depending on the event that we're discussing. Okay, looking at page 2, right, okay, I'm going to skip away with the workbook exercise question 1 and 2. Alright, so the probability of single events when a coin is being tossed, okay, usually the coin or whatever that we're doing, it is a fair object. Okay, there's such a thing called a fair coin or unbiased coin. Okay, do you know what is considered fair and what is considered unbiased or biased? We use this term very often. Fair or unbiased versus unfair or biased. So how is it that a coin is fair and how is it a coin is unfair? How do you think that can happen? Can a coin be fair? Do you think that makes sense? Huh? A coin, yes. I know coin makes sense, yes. Okay. So a coin is considered fair or a die is considered fair, right? When the manufacturing of the coin or die itself, okay, is such that the mass, okay, the weight is equally distributed around the entire coin. Okay. So if I talk about a coin, okay, we want to make sure that the coin itself is actually equally, the weight is equal all around now. Okay, so if you were to go to an illegal casino, okay, or illegal gambling then and all that, the person who actually sets up the place, okay, will most likely want to win your money, want to take your money, right? Okay, so then they may actually alter, okay, the coin or the die that is being used such that, okay, maybe on the die itself, okay, maybe more weight is placed at the bottom where it is number 6, such that you will have a very low chance of getting the number 6. Okay, so the number that appears most of the time at the top might actually be 1, right? So end up you may lose out. Okay, that's assuming that number 6 will help you to win, whereas number 1 will actually will cause you to lose. Okay, there's some ways of cheating that people actually have. Right, but of course, okay, in maths I'm not going to test you how to manufacture a fair or unfair coin, or biased or unbiased coin. Okay, what I'm just trying to say is that you will see this kind of words, right, in the exam paper itself. Okay, so you need to understand what it means. When it says that it is fair, it means that there is equal chance for every single number or every single possible outcome to happen. Okay, if it is unfair, then the question will probably tell you there might be a higher chance for you to achieve maybe a number 6 or higher chance for you to achieve a certain head or tail. Okay, so if you're talking about a fair or unbiased coin, okay, there is an equal chance, right? So the probability of obtaining a head, okay, is half, and the probability of obtaining a tail will then be equal to, what do you think will it be? Half also, right? So there will be equal chance between head and tail. Okay? Okay, whereas for a fair die, alright, if I want to talk about the probability of obtaining a number 6. So what do you think is the chance of obtaining a 6 from a die itself where there are 6 spaces? 1/6, right? Okay, I repeated it on the worksheet. Then after that, what if I say not a 6? Okay, that means that it is the remaining 5 numbers, so there are 5 possible outcomes out of a total of 6 possible outcomes. Okay, so what we see is that to calculate the probability, okay, so usually we write our probability in this manner. Okay, we write a capital letter P. Okay, E itself is the event. Okay, then we write it as equals to, okay, number of favorable outcomes over number of possible outcomes. So what's the difference? Okay, favorable outcomes is the outcome that you want for the event, right? That is tied to the event itself. Whereas number of possible outcomes is the total over here. Okay, that could actually happen. Alright? So that is how we determine probability. Okay? So it is not all the time, I want to emphasize that it is not all the time that it is a letter E inside. Okay, it depends on the situation. So for example over here, probability of obtaining a head, okay, I can write it as probability head equals to half. Okay, whereas the probability of obtaining a tail, I can write it as capital letter TP, bracket tail equals to half. Okay, then probability of getting a 6, maybe I can write it as probability bracket 6 equals to 1 over 6, and this one I write it as not 6. So this helps to shorten the words that we are trying to use and write in our presentation. You understand? So let's take a look at example 1 now. Okay. In example 1, right, we have 11 cards numbered from 11 to 21. And they are placed inside a box. One card is actually removed at random. Alright? So when it's being removed at random, that means there's a fair chance of obtaining any one of the cards. We want to find the probability that the number on the card is a prime number. Okay? So that's why last year when we look at all the prime numbers, integers and all that, those kind of words, okay, they are very important for you to be able to recognize it when it comes to probability. So do you remember what is considered a prime number? Is 1 a prime number? Is 1 considered a prime number? Who says yes? 1 is a prime number. Who says no? 1 is not a prime number. Come on, I think you need to make a decision, right? Who says 1 is a prime number? 1 is not a prime number. I'm not going to move on until I see more hands. Okay? 1 is a prime number. Who says 1 is a prime number? Make a decision. Who says 1 is not a prime number? Yes, it's not difficult to raise your hand. Okay, so why is 1 not a prime number, Sylvia? Why is 1 not a prime number? 1 is not a prime number. Why? What's the definition of being a prime number? Cannot buy? Cannot divide?
Cannot divide by other numbers.
Cannot divide by other numbers other than itself and 1. Okay. So the factors, okay, in fact to make it clearer, okay, the factors can only be itself and 1. Okay? Then why does 1 not fall in this category?
Because 1 is itself.
Because 1 is itself. Itself and 1 are both the same thing. So technically, there is no two distinct numbers over here. Okay? So when it comes to itself and 1, alright, it needs to be different. Okay? For 1, it cannot be a prime number because itself and 1 are the same. Alright? So therefore, 1 is not a prime number and you got to remember that. completing side. 2, 3, 5, 7. Is 9 a prime number? No. Okay, 9 can be divided by 3. Alright, 9 and 1. So therefore, 9 is not a prime number. So don't think that all odd numbers are actually prime number. So 2, 3, 5, 7. Then the next one will be 11. Okay, 13, 15, is it?
No.
No. Okay. So I hope I don't have to write down the whole list. Right? You need to familiarize yourself with the first few. Right? So to answer part A, looking at the numbers that we have, probability that it is a prime. Right? We recognize that 11 is a prime number, 13 is a prime number, 17 is a prime number. Is there any more that is a prime number in this list? In this set over here? 19 also. What about 20 and 21? No, right? Okay, so we only got these 4 prime numbers over here. So the number of favorable outcomes, okay, the things that we want, will be 4 out of total number of outcomes here, that's 11. So therefore the probability is 4 over 11. Okay? Next in part B, we want the probability that we arrive at a multiple of 4. Okay? So what are the numbers that are multiples of 4 in this set here? Ren, what do you think? What are the multiples of 4? Sorry, I can't hear you. 12, 16, 20, yes. So therefore the probability is 3 out of 11. Good. Okay, and then after that, part C, we want the probability of a number that's greater than 15. What would that be then? Okay, what do you think? What is the probability of arriving at a number that is greater than 15? Can you tell me what are the numbers in that list that is greater than 15? Sorry? 6. What is the number over here that is greater than 15? Can you tell me what are the numbers? 17? Sorry? And 19. These two numbers are the only ones that are greater than 15. 16, 18, 20 and 21, right? So anything that's 16 and above, right? Okay, so what would the answer be then for this probability? Probability is 6 over 11. Okay? Any questions? Right. Next one. Okay, page 3. Okay, in page 3, I have shown you a deck of cards. I printed a photo of a deck of cards. Okay, we need you to actually recognize, okay, what is in the deck of cards. Okay, so in one deck itself, alright, there is how many cards in total? Yes. Okay, so these are important information. So 52 cards in total. Alright. How many are considered black? I never pick color for you all. So what are considered black cards? What shape is considered black? Huh? Diamond is black, man. The spade and clover, right? Okay, so in each row, I'm not going to draw it out, okay? So we got the clover, the spade, the heart, and diamond. Okay, so it goes in this order. Clover first, then spade, then heart, then diamond. Clover and spades are the one that is black. Heart and diamond are the ones that are red. Okay? You need to familiarize yourself with a deck. What is in the deck of cards. So, in each series itself, is it called clover? Club. Oh yes, correct. I was thinking what is the word? Okay, club. Yes. Club, clover. Yeah, usually call it clubs. Yes. Good. Okay, so club itself, or rather, each series itself, right? There are 13 cards in it. Okay, that means that there will be how many black cards in total? 26, and there will be 26 red. Okay, and you need to know what is considered picture cards as well. So picture cards are your Jack, Queen, and King. Alright, so how many picture cards are there in total in one deck of cards? There will be 12. Understand what is in the deck of cards already. Okay, so in part A, we want to find the probability of getting a picture card. Okay, total there are 52 cards, right? But how many are picture cards? 12. So therefore, the probability will be equals to what will the probability be? Peter? Sorry? 12 over 52. However, I want to remind you, 12 over 52 is that simplest form in the fraction. No, right? So you got to press your calculator for simplest form. Okay, so always check for simplest form. So therefore, final answer is 3 over 13. So always remember to simplify answers. Probability of getting a black card. Angel, what do you think? What's the probability of getting a black card? Sorry? 26? Over 52, okay? So we get 26 over 52. Or if you're fast enough, you should notice that in one deck of cards, only half is black, half is red. Okay, so you should know that the simplest form will automatically be half. If you press your calculator 26 over 52 and our answer is not half, time to buy a new calculator. Okay? Then what's the probability of getting a card that has a heart? Actually, what do you think? What is the probability of getting a card that has heart? 13 out of 52. Okay, because there are 13 cards, they are heart shaped, okay, including the picture cards, right? 13 out of total of 52, which we also know that it has to be 1/4 of it. because 13 plus 13 plus 13 plus 13 is 52. Heart is 1/4 of everything. Okay? And part D, the probability of getting not a heart. That means that you get either club, spade or diamond. So you need to be familiar with such phrasing. They will usually sometimes do it in reverse. Okay, not a heart. So that means it is club, spade and diamond. And we know that it is 13 plus 13 plus 13. That will be equals to 39 out of 52. In other words, 3/4. Okay? So at this stage, I want you to be able to observe that when we say probability of heart, we got 1/4. And the probability of not heart is 3/4. If I add up these two numbers, what will it be? It will be 1/2. Okay? So we see that to get not heart, right? Okay? When we have this word not, it is the opposite, okay, of 1/4 of heart. So I can also say it is 1 minus 1/4, which is 3/4 as well. Okay, so when we have an event and then we have a not event, they are always 1 minus of each other, right? So conclusion, let me write it here then. Okay. So when we have an event, okay, so probability of not getting that event, it will be 1 minus the probability of having that event. So example just now, probability of not heart, it is 1 minus probability of getting the heart. Right? So in the examples that we have already discussed, we notice that for our probabilities, okay, point number 1 in the dotted box, okay, so point number 1 says that the probability of an event E occurring is such that it is always between 0 and 1. Okay, so there's the first point. If you notice that your answer for probability ends up being negative or more than 1, okay, you must know that, okay, your answer is surely wrong already, right? Probabilities are always between 0 and 1 only. Okay, it cannot be 2, it cannot be 3, it cannot be 2.5, it cannot be 1.0001. Right? It must be between 0 and 1. Point number 2, okay, when we talk about a probability of an event to be 0, it means that it can never happen. Okay, so for example, okay, an event that can never happen is a dinosaur walking into class to teach you maths. That's never going to happen. So the probability of that happening is 0. Okay? Then, probability equals to 1, alright, will be event that is surely will happen. Okay? An event that is certain. Right? So for example, I don't dare to say that the teacher that comes in to teach you maths is surely always Miss Tang, because sometimes I will be fall sick on MC and all that. So that may not be a confirmed event. Can you give me an example of confirmed event? Maybe a confirmed event is whether is Hayward sleeping in class. Maybe the probability is 1. Is it? You see, he not answering me. You understand what I just said? What did I just say? The probability of you sleeping in class is what? Sorry? What would it be then? Is it 1? Yes or no? No 1. Okay, so probability of Hayward sleeping should not be 1. Right? It should be 0. Okay, so what is another event that is definitely certain? Surely will happen, right?
Oxygen.
Probability of you breathing in oxygen is 1. Okay, fair enough. That's a very strange example. Okay. What else is confirm will happen? Confirm you passing? 23. Is it equals to 1? Nobody answer me. 0 ah? Die. Okay, let's move on. I hope it is 1 ah. Okay, don't tell me 0 ah. Okay, or at least something more than 0 lah. Alright? 0.2 ah. 20% chance ah. Okay, you all go and think about it yourself. Okay, on what is the probability. Anyway, let's look at example 3. Okay, so a letter is chosen at random from the word shenanigan. I don't know what this word actually means. I mean, I know what it means, but I don't know how to explain what it means. But it's not important. Okay? Find the probability that the letter chosen is an N. I think shenanigans simply means something nonsensical. I think. So in part A, what is the probability of getting an N in this question? From these letters over here. If I were to put them into cards and then I pick them out in cards, what is the probability of getting an N? 3 out of 10. Okay, because there are 3 N's and total 10 letters. Okay? Pause 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters. Alright? Next, understanding your English terms is important. So what is considered vowel? A, E, I, O, U. Okay? So how many vowels are there? How many vowels are there? 4. 4, right? Okay, we got E, A, I, A. So the probability of getting a vowel is 4 out of 10. Simplify it, we get 2 over 5. Okay? Then in part C, we want the probability of not getting an A. Okay, there are 2 ways for you to tackle this question. Okay, either you count, okay, how many letters here is not considered an A. That means that we have S, H, E, N, N, I, G, N. Right? So there will be 8. Okay, 8 over 10. So one of the ways is to count. Okay, and then you simplify your answer such that you get 4 over 5. Or you can count how many A's are there. So we see that there are 2 A's, so we have 1 minus 2 over 10, which also gives you 4 over 5. So if you directly press calculator, you will get 4 over 5 immediately. Okay, and this was using the concept of when we say not an event, it is 1 minus the event happening. Okay, so 2 over 10 is the probability of having an A. Alright. Any questions? Okay, next we look at example 4. Okay, long time ago there's such a thing called iPod Shuffle. Right, I don't think now we have iPod Shuffles anymore. It's a music player. Okay, I think nowadays we just Spotify from our phone. So anyway, okay, the iPod Shuffle from Apple computers is designed to shuffle and play songs randomly from a given playlist. So Kevin has X number of English songs. 125 songs are Korean songs. Okay, on his playlist in his iPod. Okay, in part A, we want to write down in terms of X the probability that the song played by the iPod shuffle is a Korean song. Okay, so we want to write down in terms of K, right? Sorry, in terms of X. Okay, and the reason we have to write in terms of X because we don't know how many English songs are there. Okay, so therefore the probability of hearing a Korean song, to write it as an expression, what do you think we will get? Wei Le? What is the probability of getting a Korean song? 125? Is that what you said? This answer? Over? 125? Plus X. Good. Okay, so 125 songs are Korean. That is our favorable outcomes. Number of possible outcomes is your total number of songs. So 125 plus X, and that will be the expression in terms of X. Okay, given that the probability that the song played is an English song is 4/5. So the question gave you that the probability that it is an English song, it is 4/5. Then they want you to find value of X. So you're going to work in reverse. Okay, the question tells you what is the probability already. So let's maybe form an expression in terms of the probability of English song first. Right? What do you think is the probability of having an English song? How will you write it out? Deborah, what do you think? Okay, X over 125 plus X, great. So that will be the probability for English songs. Okay, and we know that it is equals to 4/5. So I can say this. And I achieve an equation. I want to find the value of X. How will I be able to do that? Howard, what do you think? How will you solve for value of X? Sorry? I can't hear you. 4/5, then equals to, did you say equals? Equals to? X over 125 plus X. Isn't that same thing? Then cross multiply. You don't need to change it to like that, then cross multiply. No. You can just cross multiply directly already. Oh, sorry. Okay, so we can just cross multiply like that, alright, and we will get 5x equals to 4 times 125 plus x. Okay? Then after that, alright, I will have to expand it. Okay? So 4 times 125, I will get 500, I think. 625. If it
1x
for 500, right? Yeah. Okay, so then we solve. And we see that x is equals to 500. Okay, so there will be 500 English songs in his iPod. Right? Any questions? If no questions, I'd like you to turn to your workbook now, page 156, before it's time for you to wake up. Okay, workbook page 156, I want you to do question 3, 4, and 5. Answers, yeah? Right, got only a few minutes left. Okay, I want to say that question 3, all the answers on the whiteboard are correct or wrong? Wrong. You go and use your fingers and count. There is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, got 15. Oh, 14, 14, 14. Then this one 15, but the answer is still wrong. Okay? So, let's take a look. Part I. Okay, how many 21s are there? There's only one. So answer is 1 over 15. How many odd numbers are there? If you really go and list them all out and count, okay, answer should be 7 over 15. Whereas the number of prime numbers, that is really 5 over 15. Okay, simplify that, we get 1/3. The prime numbers that are found in this question, okay, is 11, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, these are the prime numbers, right, found in the list. And then perfect cube, I already gave you an example, 8, 27, 64. Any number as long as you cube root. So you can go and slowly cube root every single number. You realize that none of the numbers can be cube rooted to get a whole number. So answer is 0. 16. 4 to the power of 2. They cube root that. 4 to the power of 4 give you 16. But 16 you cannot cube root to get whole number. You try again, cube root that. Cube root, not square root. I say cube root. Okay? Unless I say perfect square, then yeah, 16 can. Okay? Alright, so answer is 0. Part 5, multiple of 3. Okay? You will find that you have your 12, 15, 18, 21, and 24. So that is 5 numbers in total. Out of 15, answer will be 1/3. Okay? Question 4, red card is half. Number of A's, there are only 4 A's out of total 52 cards, so it's 1 over 13. I'll write it bigger. Then picture card, okay? There is only 3 picture cards. Wait out. Sorry. Answer is 3 over 13. There are total of 12 over 52, which simplifies to 3 over 13. So simplified answer 3 over 13 is correct. To get not a picture card, answer is 10 over 13. You can take it as 1 minus 3 over 13. And answer will be 10 over 13. Right? Probability of getting a B is 2 over 11. That's correct. A consonant, 7 over 11. So therefore I already addressed, a consonant is a letter that is not a vowel. Right? Probability of getting an I or Y, there is 2 I's and 1 Y. So 3 over 11.